Welcome to AI and Tech Insight by Usama Toomey. Here, we explore artificial intelligence, cybersecurity, emerging technologies, and innovations that transform businesses and our daily lives. Modern DevOps is built on fragmented operational states. An engineering team stores their architecture diagrams in one platform, writes automation scripts in a second, and tracks infrastructure health in a third. Because these systems operate independently, technical documentation rots. The moment an engineer makes a hotfix in production, the corresponding runbook begins to diverge from reality. Standard AI assistants cannot bridge this gap because they are stateless. They lack the persistent, cross-session memory required to understand the specific nuances of a unique infrastructure over time. Automation engines provide execution, but they remain rigid. If an API returns an unmapped edge case, the workflow halts and waits for manual human intervention. Solving documentation debt requires moving past separate silos and implementing a closed-loop architectural model. A truly autonomous operational architecture requires three specific primitives: execution, memory, and reasoning. We can achieve this by integrating three specific tools: Obsidian, N8N, and Hermes AI. Obsidian serves as the persistent, queryable knowledge graph. It stores the structural truth and the long-term context of the system. N8N provides the execution layer, serving as the workflow engine that handles API calls and production scale. Hermes acts as the orchestration layer. By utilizing the Model Context Protocol, Hermes bridges the memory stored in Obsidian with the execution capabilities of N8N. Binding these tools together establishes a framework where documentation serves as the active source of truth for the live environment. The first mechanism of this architecture is the forward loop, which translates static knowledge directly into live execution. The process begins when the Hermes agent utilizes a read file command to scan a markdown list of target URLs stored inside an Obsidian note. Hermes then autonomously cross-references this raw text with the current N8N SDK syntax guidelines. During the compilation phase, Hermes writes the JSON code for a new N8N workflow, such as a daily price monitor based on those URLs. To deploy, Hermes triggers the Create Workflow from Code tool, pushing the generated logic directly into the N8N engine. The system then generates an architecture dependency graph back inside an Obsidian JSON canvas, using the tags from the newly deployed workflow. This cycle ensures that the live infrastructure mirrors the written documentation precisely, because the documentation is what generated the infrastructure. We also need to solve the inverse problem: active production environments generating operational data that never makes it back into the company documentation. The feedback loop addresses this. Take a standard lead gen v4 workflow as an example. As the workflow runs, it processes thousands of items and encounters specific retries or errors before completing its task. Once the run finishes, a post-execution webhook automatically fires the raw performance data back to the Hermes agent. Hermes processes these stats and appends a structured table and root cause analysis directly into the corresponding Obsidian note. Every production run serves to upgrade the institutional knowledge base without manual human intervention. The ultimate test of this architecture is a live production outage. Suppose an active N8N workflow encounters an HTTP 429 rate limit error from the ThreatFox API. The N8N error workflow triggers immediately, sending a webhook directly to Hermes. Hermes begins triage by fetching the raw execution logs to identify the exact failure timestamp. It then searches the Obsidian vault to read the existing ThreatFox rate limits documentation. By cross-referencing the logs with the documentation, Hermes identifies an hourly cron collision causing the API block. The agent proposes a programmatic jitter and exponential backoff configuration to resolve the issue. Using the update workflow command, Hermes autonomously deploys the new retry configuration. Simultaneously, Hermes rewrites the known issues documentation in Obsidian to include the incident data and the applied fix. The agent has moved beyond the role of a passive assistant. It is now an active reliability engineer managing the system state. Moving from technical capability to measurable engineering velocity reveals the true value of this stack. This data highlights the time savings. Building a medium complexity workflow drops from a 4-hour manual task to roughly 30 minutes. Debugging production failures shows a 90% reduction in time as the system handles the diagnosis through the root cause loop we observed earlier. For new hires, onboarding shrinks from weeks of reading stale wikis to mere days spent navigating the auto-generated visual canvas. This investment pays off by significantly reducing the manual labor required to keep documentation and production state in sync. This architecture functions as a single system with 3 specialized interfaces. Obsidian serves as the brain, managing the context, visual history, and institutional knowledge. Hermes acts as the hands, performing the reasoning and delegating tasks to specific tools. N8N operates as the nervous system, providing the reliable execution and API scale. Each new workflow added improves the agent's internal skill library, which accelerates the development of the next task. For high productivity teams, treating documentation as a living, executable artifact is the ultimate strategic advantage. In this environment, the docs are the code, and the code is the docs.